Hello students, welcome back. In this video we are going to continue our review of some of the key concepts from Stats 1 before we really get into the meat potatoes of Stats 2. So here is our data set again from the previous video, the ages of actors at the time they won an Oscar. And in this video we are really going to focus on graphing this data. So we're going to display this data using histograms, box and whisker plots, and stem and leaf plots. First is a box and whisker plot. Here's your box, and apparently this is a whisker, and it looks like a cat's face, apparently. That's the nose, and then the little whiskers on the side. So over here, this is the lowest observation, or I like to just call it the minimum, the smallest data value. Over here is your highest observation, or your maximum. Right in the center right here is the median, and it doesn't always have to be evenly length sides. The median is just whatever your middle number is. And then we have a Q1 and a Q3. Okay, so we know what median, minimum, and maximum are. So what is Q1 and Q3? Q1 and Q3 are interquartiles. So, like the name suggests, a quartile divides the data into 4 equal-sized groups. So the lengths might not be equal, but the number of data in each of the number of data points in each of these quartiles would be the same. So Q1 is just going to be the median of the lower half of the data. Q3 is going to be the median of the upper half of the data. So I just gave you a real quick example. We have 1, 2, 3, 4, 5, 6, 7 data points. So the overall median would be 60. You have 3 that are below, 3 that are above. Q1 is going to be the median of the lower half of the data. So the lower half of the data would be 50, 52, 54. That would be 3 data points. So the median of the lower half, Q1, would be 52. And then the same for the upper half. So we have 63, 66, and 70 as the upper half of the data. The median of that would be 66. So your TI will calculate Q1 and Q3 under one variable statistics. I showed you how to get to this point in the previous video. So once you're here, you can scroll down, and then you will find Q1 would be 37, and Q3 would be 51. Outliers. So now we're going to talk about a box and whisker plot with outliers. You might remember from Stats 1 that outliers are data points that are considered to be outside of the normal range. Outliers, outside, you can kind of think of the connection. So it's a number that's kind of far from the rest of them. And outliers can be considered extreme on the lower end, mild on the lower end, mild on the high end, or extreme on the high end. And I'm going to explain how you would do that. So how would you quantify an outlier? So first you have to calculate what's called the interquartile range, which is going to be the value of Q3 minus the value of Q1. So the interquartile range is 14. So there are 14 ages that 50% of all the data fall. So 14 is your interquartile range. So next, you would calculate these 4 little calculations. So you have Q1 minus 3 times your interquartile range. So Q1 was 37. 3 times the interquartile range would be 3 times 14, which is 42, equals -5 for your extreme low, which would mean that anything lower than -5 would be considered extremely low. Now, since we're talking about ages, clearly nobody is going to have an age less than -5, but that's just how you would calculate it. So a mild low range would be Q1 minus 1.5 times the interquartile range. So 14, which is your IQR, times 1.5 is 21. So 37 minus 21 equals 16. So anything between -5 and 16 would be mild, a mild outlier. Then for your mild on the higher end, we have Q3 plus, notice the differences about what's changing. So it's Q3 plus 1.5 times the interquartile range. So again, 14 times 1.5 is 21. 51 plus 21 is 72. So 72 starts your range of what's considered a mild outlier on the upper end of the spectrum. And then finally, an extreme outlier on the upper end would be Q3 plus 3 times your IQR. 3 times 14 is 42. 51 plus 42 is 93, which would give you an extreme value. So anything between 72 and 93 is mild on the high end. Anything 93 or greater would be extreme. So let's look at our data points. We're looking for any data between -5 and 16. So our minimum is 31, so we would have no data points that would be considered an outlier on the lower end. And then on the higher end, we're looking for 72 to 93 or above. 72 to 93. Okay, this 76 would be considered a mild outlier, and then there would be no extreme outliers. So now the next thing that we are going to look at is the stem and leaf plot. Stem and leaf plot represents quantitative data by spreading each value into two parts: the stem, which is the leftmost digit, and the leaf, which is the rightmost digit. So features of a stem and leaf plot: it shows the shape of the distribution. So you can kind of see this is the 30s, the 40s, the 50s, the 60s, the 70s. It retains the original data values, which that's going to come into play when you do a histogram, where you're just showing you your classes rather than the individual numbers. And then finally, the feature of a stem plot is that the sample data are sorted. They're arranged in order. So kind of showing here, the way that this StatCrunch plot did it was it separated each of the first numbers into the lower and upper. So the first one will be 1 through 4, 5 through 9. Or I should say 0 to 4 and then 5 through 9. 0 to 4, 5 through 9. 0 to 4, 5 through 9. 0 to 4, 5 through 9. And so on. So notice that there's 60, 60, 61, 62, and then there's nothing between 65 and 69. Nothing between 65 and 69. Nor is there anything between 70 and 74, but there is a 76. So again, that would be 31, 32, 32, 32, 33, and then so on. Finally, a histogram, which is the most important of all of these. So a histogram is a graph consisting of bars of equal width drawn adjacent to each other, unless there are gaps. The horizontal scale represents classes of quantitative data values, and the vertical scale represents frequency. So how do we construct a histogram? So first, you select the number of classes that you want to have. Usually you want to have between 5 and 20 classes. Classes would be, this would have 1, 2, 3, 4, 5 classes. How many classes that your total data value is going to be divided into. Once you have how many classes that you want to have, your number, then you divide by the class width. So the class width would be your range, which is your maximum minus your minimum, divided by the number of classes you want to have. Typically, once you get that number, you want to round up to get to a convenient number. Like you don't want to have your ages be 5.4 or whatever it would come out to be. You want to use numbers that are convenient to use, maybe a 5 or a 10 multiple, or just a good solid whole number. Okay? Then you choose the value for your first lower class limit. You can either use the minimum or that, or a convenient value below the minimum. So for our right here, we might want to do a class width of 10, separate these out by the 30s, the 40s, the 50s, 60s, and 70s, and we want to have our class start not at 31. Let's just be convenient and have it start at 30, and then have this go up until 80. Okay? So then you create your lowest class limits and your class width, and then we will plot it. So let's go straight to it. So we're going to have it start at 30 and go to 39. That would have a total of 10 data points. And then 40 to 49, 50 to 59, 60 to 69, 70 to 79. And then we're going to go through and just count how many times it goes through. So how many in the 30s do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13. So 13 would go right here. And then so on. I think you can kind of see how I fill this out. And then you plot it. So this is your 30 to 40 range. And then it goes up to the 13. 40 to 49 will go all the way up to 16. And then so on. A few definitions. The lower class limit would be the smallest number that can belong to each of the different classes. The upper class limit would be the largest number that can belong to each of the different classes. Class boundaries, this can be a little confusing. And a lot of my Stats 1 students get this wrong, so I would recommend paying attention to this part. It's the numbers used to separate the classes, but without the gaps created by class limits. Basically, you would need to factor in rounding. I'm going to explain this a little bit in 2 slides, so bear with me for now. Class midpoint would be the values in the middle of the classes. So each class midpoint, you just have to do the mean of the lower limit and then the upper class limit within each class. Finally, the class width is the difference between 2 consecutive lower classes. Okay, so let's show how we get each. Lower class limits. Let's kind of go back and forth to the definition and then show you how you calculate it. Lower class limit. Smallest number that can belong to each of the different classes. I have 1, 2, 3, 4, 5 classes. The lower limit is 30, 40, 50, 60, 70. Upper class limits. The largest number that can belong to each of the different classes. 39, 49, 59, 69, 79. 5 numbers. Class boundaries is the numbers used to separate the classes. So it's not just as simple of 39 and 40. Because what if you had 39.5? Well, that has to belong to one of the classes, so you have to factor in rounding. So we're going to look at the difference between a 39 and a 40 and see, okay, there is a 1 number in between the 2 of them. So we're going to have 0.5 be what separates the boundary. So minus 0.5 from here would be 29.5. Then it would be 39.5, 49.5, 59.5, which is halfway between 59 and 60, 69.5, which is halfway between 69 and 70, and then add another 0.5 to this. So 79.5 would be the largest value that can land between this class. The class midpoint is going to be 30 plus 39 divided by 2, 34.5. 40 plus 49 divided by 2, 44.5. You can kind of see the trend from here. So you're just going to add 10 each time. Same with this. You're just adding 10 each time. So that's 34.5, 44.5, 54.5, 64.5, and 74.5. Finally, class width. And I know you're going to be tempted to say, oh, 39 minus 30, boom, 9, good. But that's not what a class width actually is. Class width is the difference between 2 consecutive lower class limits. 40 minus 30, that's 10. And the reason why it's that is because if you count 30 to 39, including the 30, you have 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. You actually have 10 numbers that it can possibly be, not 9 that you would get if you just did 39 minus 30. Okay, so now we just did a histogram. Now we want to do a relative histogram. A relative frequency distribution represents each class is replaced not just by how many times it appears, but by how much of a percentage of the overall that it can be. So relative frequency for a class is the frequency for that class divided by the total number of frequencies. And that will give you a decimal value, or you can represent it as a percentage. So let's just go right to it. The sum of them will be very close to 100% when you add them together. Okay, so right here, these 2 columns we just did a few slides ago, but now we're going to do a relative frequency. So again, you take the total number of occurrences and then you divide by the total number of data points you have. So for class 1, which has a lower limit of 30, upper limit of 39, you have 13 occurrences, divide by 39, a third of the data falls in this value, and you can do that as either a percentage or a decimal. The second class width right here, you can have 16 total occurrences or 41%, so on. And then if you add them all together, you should get pretty close to 100%. You might have a little bit of a variation, but that's only because of rounding. And then if you add up over here, you can see that you get 39 total data points that are accounted for. The other type of histogram is a cumulative histogram. So cumulative means that you are going to accumulate or add frequencies starting at 0. So the frequency for each class is the sum of the frequencies for that class and all the previous classes. So you're starting at 0 and then you were ending at 100%. And then you're just showing you at what point, at this class, what total percentage of the data values have you already encountered. So it's up to and including that number. So starting at 30, we have 13. So this one's going to be the same. Then from 40 to 49, the cumulative frequency is going to be your 16 plus 13, or 29, or 74.3%. The 50 to 59 is going to be your 29 plus 5, or 13 plus 16 plus 5, for 34. So at this point, you have 34 of the total data values that have occurred. 87% plus another 4 is 38, plus 1, 39, and boom, we end up at our 100%. So that is the end of this video, guys. Thank you.